Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, well, it's my pleasure today to introduce to you John Tong from IBM Almaden. John is here to talk to us about, John is a research area staff member, and he's here to talk to us today about Consolidarity, exploring patterns of social commonality among file directories at work. John's interests are very much in line with many of those in our group on supporting task management, task switching, and I'm sure he'll talk to us about some of that research today. John?
Great, thanks. It's great to be here and among a lot of friends that I recognize. So this is, as Mary said, a project called Consolidarity, which was done with a group of people at IBM, including Fei Wu. He was a summer intern from University of Washington. And this is actually a bit of a different talk. It's very much a research exploration. And in some ways, we didn't get to accomplish the things that we initially set out to do, but we learned a lot along the way. And so this is a bit of a talk that walks through the journey that we did in learning about it. So Consolidarity tries to build on the rise of popularity of social recommending, at least in the consumer space. I think we're all familiar with Amazon, which takes a look at their high volume transactions of book sales and allows you to say, if you're interested in this book, which I would highly recommend actually, then you might be interested in these other books based on analyzing all the books that other people have bought. And so we thought, well, what would be the analog in the enterprise work world? And we wondered about, at least for knowledge workers, perhaps the high volume transaction that we do is store or manage the files that we have and put them in folders and directories in an organization on our computer. And so we're doing that all to help us retrieve those files later on. As a company, could other people benefit from the work that each individual is doing in organizing their work? So can we leverage the individual file management that people are already doing that in a way that other people in the company could benefit from it? So we're saying, is there some commonality in files in the work setting? For example, if you and I have some document or collection of documents that are in common, it may reflect some shared interest we have in a topic. I just downloaded this report from the web, and I think this might be more popular in a web world, right, where a pervasive search is returning similar things. So I download something from the web. Who else has looked at this that might be able to tell me more information about it? Or if you and I have some applications or developer libraries or downloads in common, it might indicate that you have some usage experience that I might benefit from. So, who else uses this library that might help me with a problem or a question about it? So we were wondering if we could put that commonality, that is discovering you and I have files in common, to work by connecting people through the information that they have in common. And this is very much a research question. Are there interesting patterns that we could exploit? So we were thinking this could actually be a way of connecting people more closely with information, because in general I think the web currently provides a lot of information, but you often don't know who that comes from. And in a work setting, you want to know people to form teams or to collaborate with. This also has as a benefit, because we're all constantly managing our own files, that profile is being dynamically updated, as contrasted with filling out a profile on a website that kind of ages and you have to manually keep updating it. And we were interested, although we didn't get very far, in wondering if there were some transitivity effects. That is, you and I have file A in common. I put A in a folder with these other files. Could you discover this other information through this commonality through me? So that's what we started off wondering, whether there were some interesting possibilities. And we took a research approach where we collected data from a set of volunteers. And we analyzed the files that were on people's hard disks to see if there were patterns of commonality. Now, we only looked at metadata, so the file name, the file size, last accessed or last modified. And then we looked at a hash algorithm on the bytes of the file. So we're not looking at the actual content semantically, but we're looking at a kind of a proxy or representative content by hashing the entire file length.
I assume you're looking at path as well, since you were talking
yes, exactly.
trying to capture
Yes.
organization.
Yes, yes. So we once we find a file in common, we can see where it's situated in each other's. So that's part of the metadata that we're collecting. And then we were comparing for matches among others in the data set that we collected.
Were these people co-located? Were they a work group?
They were not all co-located. They were not all in the same work group. But it's a bit of an arbitrary. So we'll go in a little more detail about the people. But it was volunteer, opportunistic at this stage. So the premise was that we could do this with no or very minimal added user effort, right? So people are just managing files the way they usually do, and we're kind of just scraping it and doing some analysis offline. And we were wondering whether this could provide some social benefit of discovering related people and related information.
Were you also tracking changes to the organization over time?
Were we tracking changes to over time? This was a snapshot. So this is, and that's one of the things that we were tracking, though, was last access or last modified dates on the file. So we could have a sense of how current or recent the usage of the file was, but you might be asking about then how much was the organization changing during that time. So I can't say that we looked at that explicitly. So we were looking at a kind of a snapshot of data with a snapshot of the organization at that time. Although you'll see some of the interesting things, reasons why that would be interesting to explore. Yes.
So just to follow up to that question, I'm assuming, were these all on Windows PCs?
Not all Windows PCs at first.
So the reason why I'm asking that is because the last modified and last access date can be really unreliable.
Yes. So we discovered last access and last modified date are not reliable. That's one of the things we discovered, although maybe you guys already knew that. Yes.
Okay.
And frankly, one of the things that I think this research has taught us is what is useful metadata to capture and to preserve. Later on, I have this slide on, actually we call it temporal pollution, where a lot of things are touching those dates and they don't really mean the user touched them. And so maybe we need to think of some sort of conservation campaign to preserve metadata that's important to us, and also to record metadata that would be useful to us, like all the people that have touched the file. So I think that's an area that would be interesting to explore if we want to do more of this mining of data patterns work. Okay, so you might have some reactions that there are some privacy issues about this, and privacy issues are definitely part of the research. We think that privacy in a work enterprise is a little bit different than in a consumer space. Some people have noted this in the past. At some level, right, in a corporation, the corporation owns all the information on our computers, and of course, we only do work on the computers that our corporations give us. We even need to have some mechanisms for excluding certain folders. So one example is paper reviews. So the author and the reviewer have the PDF of the paper in common, and so you wouldn't want that to be discovered. But of course, since we're doing this at a corporate level, I can't review papers submitted by people submitted from IBM. So in a sense, there's some social structure that avoids some of the problems. But there are certain job roles like legal and HR, or certain companies that they set up competing teams to work on the same project, so you'd have to kind of figure out how to separate or firewall them. There are some subtle interactions, I think, that you'd have to watch out for. But that's part of what we wanted to explore. We wanted to figure out if we could give users awareness and control of how this information was being used, and so that they could make informed choices about, the benefit is worth this privacy exposure. And the other thing is that the enterprise has mechanisms for dealing with privacy violations. And if you do something inappropriate, the corporation can, issue out some consequences. And that's different than the consumer space, right? You can't really control if someone, it's harder to control if someone abuses something. For our particular study, we allowed participants to exclude any directory branch before uploading it for us to analyze. And again, we reminded them we're not doing any semantic analysis of their data. So we're not learning about what they're doing. We're detecting matches between other people. The overview of all the data was limited to the research team. So that's a list of people that were on the authors, unless we anonymize the visualization, and you'll see some examples of that later on in the talk. And the other thing is that we only disclose files that, as to the end user, that they have in common with other people. Okay, so in a sense, that mitigates some risk. I can't discover that someone else is downloading unseemly material on their computer unless I'm actually doing it too. And then my perspective is different. There's a different social way in which I would.
Doing it for research purposes.
Right. So this was an interesting way where we said, okay, you're only going to be able to discover stuff in common. You're not going to be able to uncover things that people are doing.
So that's the transitivity.
Right. So, and one of the reasons why we haven't gone there yet is that does step into a different space. But in general, I think this also highlighted to us the need to explore dealing with privacy issues in mining of large aggregations of data. So I think we all know that large companies are offering services that we appreciate on data that we're volunteering to them. But I'm not sure. I think the research community could do a service of providing more principles or guidelines about what's appropriate, how are people made aware of the implications that they're making this data available to be mined in that way.
So this would limit you from being able to find people that are expert in an area that you're not expert in because you're not likely to share things.
Well, depends. So one model where we imagine this might happen is if you search the web and you download some report about a topic that you're trying to find out about, it potentially could match. And in fact, one interesting thing is that these kinds of matches could be matches with experts or fellow explorers, and it'd be up to socially for you to figure out how to proceed on that. So our approach actually, you'll see a little bit more of this, was to give cues to people who could then we're always letting the inference happen at the person and the social level. So you get cues, you have this in common. Hopefully you'll have a range of people that you have some commonality with, and then you decide, well, this one's the person I know the best or is the most approachable that I would then take the effort to kind of contact. Okay. So, commonality. So first of all, in analyzing the data, we discovered there's a lot of redundancy even within a single user's hard drive. And you actually may be more familiar with this than we were. I think this is subsequent downloads or common files among versions. Anyone want to guess how much commonality within a hard drive you have?
25%.
Yeah. 80. Okay. So in the in the data that we data we have, number of files about 25% redundant. The median is lower, so there's a bit of a longer tail. In terms of volume of space, it's about 14%. So reflecting just within an individual hard drive, there could be some opportunities of saving. So, okay, now thinking of.
So sometimes there is intentional redundancy because we don't have file systems that let you tag things, so you have to store it in multiple places if you're.
Right.
But then there are a lot of times when it's just failure of your own memory that you've seen this thing before.
Right, in terms of whether the redundancy is intentional or not, in any case, I think there's an opportunity for more efficient structuring or linking of files, even within.
I assume that you specifically eliminated operating system.
No, not yet.
That's going to give you a lot of redundancy.
Yes. Okay, so moving on to that question. See, I know this crowd. Talking to an OS system company, I think you already get some of this, but some of it was still surprising to us. So thinking of all the files that you have in common on your computer and thinking of someone that you work with closely, do you think you have less than 100 files in common, or less than 1,000, or less than 10,000? Anyone?
Well, are we including the system files?
Yes, we are. But we're including only unique files.
If you're including system files, then it must be a really large number.
It is. It is a really large number. Okay, so from 15 computers, 13 of them were Windows, but 2 of them were Linux. So we were looking at cross-platform differences. On average, it's over 15,000. On median, about 14,000. And it's about 20%. So you and I...
Do you have a way of factoring out the system files?
Yes. Well,
We found that everybody had this overlapping fascination with operating systems.
Yeah. Well, people had overlapping experience in using operating systems and dealing with problems with operating systems. Right. But on average, a fifth of the files we have in common, which we thought was kind of high. And if you look at the aggregate, so that was on a pairwise basis, any two people. So if you look at the aggregate, all 15 computers, and you compare the number of unique files with the total number of files that are stored, then on aggregate you have about 54% of redundancy of number of files, and that's 32% of volume of files storage space. So that was kind of interesting and actually led to or kind of supported a project that was going on at Almaden for a backup and restore system for a work group or an enterprise, where you could streamline the backup of a work group by skipping files that are already backed up either by you or by others using the same server. So if 10 of you have you share a copy of one file, the backup system only has to store one copy of that. It only has to store one copy of it and can serve up a restore to any of the 10 of them.
Although sometimes the place where they're located is important, right? So.
But you can store the metadata information.
Yeah.
You only store one copy of the file. You store the metadata information so that you can replace it.
Sometimes it's going to be about the same size as the file, but
I see.
maybe not on average.
I don't think so. Right. So in our data, there's
files, things, fonts, and things like that.
yeah.
So
Yeah.
by doing that, are you increasing your chances of a catastrophic failure if you only have
One copy of that.
Well, it's on.
and that copy fails?
Okay, you can always have two copies.
They send
Well,
one
you
to
can always
the other
restore
side
it
of the
from somebody
planet.
else's machine. Right?
Yeah.
So I'm not
One
sure.
of them would have to fail plus the backup.
Right.
If 10 people were sharing.
That's true.
That's true. I'm feeling bad for the camera audience because I can't quite reconstruct all the conversation. But there are some interesting. You're right. Knowing that 10 people share it could point you to other people besides the backup store that's being stored centrally. So theoretically, though, it saves backup storage space and the network traffic of all this unnecessary transfers. And this is the interface to LiveWire, which shows you in red if it's encountering a file that it doesn't need to back up. It's called redundant file elimination. And we were just noticing how much that occurs. That kind of led us to even further explore this artifact. But this is being turned into a product, which I think is a cool idea for any enterprise backup and restore system. But back to the questions you were talking about earlier, a lot of the commonality is not interesting or very meaningful. And we needed to take some steps to try to filter out the noise. And we stepped through the ways in which we tried to focus on finding meaningful commonality. So as you guys already noted, a lot of it is operating system or Office applications or Java or all the stuff that our IT department loads on the machine before a user ever touches it. So we wanted to try to filter that out. And we did a couple things. We took a machine that we called a clean machine before any user touched it, but after the IT department had configured it. We subtracted all that from the data. Then we took a term frequency, inverse document frequency. So anything that was more than 70% of the people had in common, we figured that's not very interesting either. So we subtracted all that data out from our data set. That's a bit like an automatic blacklist. We also subtracted files that are less than 200 bytes because a lot of applications, they set up a dummy scratch file. And if it's 0 bytes, it matches everything else. And so we subtracted all those small files out.
So what was in those greater than 70% common files, which are not in the clean machine?
Yes. Okay. Why did you have to do both? And it's a little bit of a mystery for us. But for one thing, the clean machine is a moving target, right? Every computer that our IT department creates over time is slightly different because of different versions. So we thought TF-IDF would be more current in that sense. But in fact, both of those subtract unique files from each other. There's a lot of overlap.
The TF-IDF is only based on metadata, not on content, right?
It's the hash of the files, right? That's correct.
So do you have a sense for what kind of files? So it's maybe like some other version of the operating
Right.
system?
Right, different versions so TF-IDF as opposed to clean machine, a lot of people will download Google desktop search or very popular things that a lot of people will do, but our IT department doesn't put on. Okay, the other thing was we needed a mechanism to identify files that were similar but not identical. There are a couple of reasons for this. First of all, we were interested in slightly different versions of files, which we'd like to have those as matches. But second of all, there's if you send a file by email attachment, depending on whether you do a direct copy, like drag it as an attachment into a folder, then the fingerprint, the hash, stays the same. But if you open it up in an application and then save as into a different, see, you guys know this, but it changes, it fundamentally changes, it embeds the last modified date in the file, and then it gets compressed, and so the fingerprint is different. And we discovered that there were a lot of files that we knew we had in common that were not coming back as matches because we knew we shared them, but it's because some people will open it up and save it, so it doesn't come up as a match. So we needed to, and this is just some data if you needed to be convinced. Even files like PDF, in the latest version of PDF that allows you to fill in fields, that causes a change if you save it differently. So on average, there was a difference in file length of 11%, which meant that the whole algorithm was off. So we went to a technology that looked for partial file matches, basically. LiveWire actually breaks files into smaller pieces, into these natural chunks, using a content fingerprinting algorithm. And we could identify chunks of a file that were in common. We use a chunk size of about 32K. And if the matches of the chunks amounted to over 20% of size, then we returned it as a match for us to consider as similar. So I have to say, when people describe this, I was very skeptical that this would actually find the things that we wanted to. But after experience with it, I'm going to show you an example of a match. These are 2 PowerPoint files. Okay, they're over a dozen slides each. And it was returned as a match. And when we sat down and looked at the files, it turns out that they have this image in common between them. And that was enough of, but you'll notice that the text around them is different. That was enough of a match to trigger this 20% rule, and it kind of kicked it back as a match. And these are the kinds of similarities we were interested in finding. And so
like if 2 PowerPoints have the same background graphics.
Right.
But did you look at plagiarism detector?
Right. Okay. Oh, okay, so the question about background, it comes up, so that has to do with whether the 20% threshold is accurate enough, and I'll say a little bit more about that later. The plagiarism detection, that's a good, I don't know that we explicitly looked at that, but was that based on textual analysis, or did it do non-textual content?
I think there are a number of different plagiarism detectors, and some of them certainly are, the basis is textual content. Right. So one of the things, you guys are skipping ahead, but that's okay, is that this approach complements it by looking at non-textual or graphic. So we were able to find graphic or even video content in common, which I think complements a lot of the text-based semantic analysis. Yes,
so
Ed.
With textual or text-based, or video, I'm trying to understand what in the metadata that's creating this hash that's equivalent. I mean, you just have size and you have a little other metadata. Is it like just bits per second? And stuff like that?
Well, so no, but it's the hash of the file itself. So, and actually at this level, it's hashes of chunks of the file itself, and that the chunking actually happens in a way that these images are they're being chunked the same, and then you can compare them and see that you're in common. So we are looking at that. That's sort of a proxy for content, but not right. Okay, so anyway, we had enough of these matches that I got convinced that the algorithm was returning the kinds of matches that we would be interested in. The other approach we did was to focus on specific file types, that is, types that the user would be more involved in touching. And we divided them into 2 groups: productivity, Word, PowerPoint, and software developer, which in our company means C or Java programming or using various developer tools. Okay, so this, if you're interested in the details, gives you a sense of how much our filtering mechanisms affected the data. So without filtering, each computer on average had 134,000 files that we monitored. After the filtering, that goes down to about 83,000 files per person. If you only look at productivity files or only developer files, that's actually smaller. And then furthermore, if you only look at similar, not identical matches, contrasted with identical matches, that's obviously much smaller again. So kind of zeroes in on the kinds of files that we think are more interesting to look at. Okay, so here's a visualization of the kind of matches that our data set shows. This is 14 Windows-only computers. These are computers or people organized on the vertical axis, and projects that they are currently working on along the horizontal axis. So the size of the node is how many files are in that computer, unique files are in that computer. And the edges, the thickness of the edges, is the number of matches. In this case, either identical or similar matches between those two nodes.
How did you go from document to project?
That's external knowledge. So these are basically people and the project that we know them to be working on currently. So first thing to notice is that, right, it's not uniform. There are differences. Some people have a lot in common. Some people have sparse in common. Some people there's some notion of a pattern of a hub that is a person that has a lot in common with a lot of people, as opposed to people that have a lot in common with one other person and not so much with other people. Now, in this visualization, you would expect a lot of vertical lines, so people working on the same project having a lot in common, and there's certainly evidence of that. This pair here, a bit on this project here. But there are also these, interesting to us, diagonal, these links across projects, which may be the more surprising links. And these two in particular, between this node up here and the bottom, there's a lot in common. And that link was surprising because knowing those two people, they're in different job roles, different projects, different organizations, why would they have stuff in common? And we asked them, so what do you know about Ed? And they said, I have no idea why I'd have a lot in common with him. So we actually invited them to review the data together. This is a little bit tricky in terms of privacy implications, but we said, okay, if we all came together and we let you open up files for other people to see, to discover what these matches mean. So we sat down and had a session and discovered, for one thing, they had a very large related software system. It was Eclipse and Rational. They're not the same system, but they're on the same code base. So there was a lot of files that matched simply on that. Furthermore, one of them had an extensive versioning strategy where they made a file, they made a change that was a different name, they made a change that was a different name. So anyone who has that strategy will generate a lot of matches with anyone else that they meet. But remember, there was this unusually high match with this one person. So the most interesting thing was that there were some slide images reused. So this one person made a talk, and another person saw it and included images into talks that person made. And that person's role was actually to pitch proposals for funding throughout the company. And they had included that. And in fact, that's the image that I showed earlier of the two slides that had that film strip image in common. So interestingly, they did not know that they had this in common. And they said, it would be interesting to know that this other person liked this research and was kind of pitching around the company.
Bordering on the plagiarism.
Bordering, it is. And we were worried, since we saw the match, we were worried about what was the right way to ask them about it. Would the person, first of all, we actually didn't know who was the source and who was the copier, because from the data we couldn't tell. So we didn't know who to ask first or how to which is why we opted for this group approach. But in this particular case, they were intrigued to discover it, and they would have liked to have known it was happening at the time. But in general, it was more exposure for the project. So they were interested to know that happened. Okay, but it is also true that this discovered some false positives. So there were some, if you store a blank PowerPoint template and other people use that template, so on your side, it's going to match 100% with anyone else who uses that template. So we would have to deal with that. Or my other favorite example is that they had stored, our cafeteria prints a PDF of the menu for the week, and 2 different weeks showed up as a match. And we thought, this is evidence. The cafeteria menu never changes, from week to week. But in fact, it was the graphic, border around it, and the menus were actually different. So this suggests that we'd have to be a little smarter about how we'd parse the data. Okay, some other visualizations, the same organization, people along the vertical, project along the horizontal. So looking at developer file types, identical matches only. Again, you'd expect these vertical lines, which happens, but these diagonal ones are potentially interesting because people could be using software components and they would not be aware of it because they're on different projects, but they could have some useful usage experience that they could benefit from if they only knew about that. So there's some indication that there could be some interesting experience to find. And then this last one on productivity file types, similar only, not identical. The thing to note is that the scale is much smaller. The number of matches and the number of nodes is much smaller. Again, a lot of vertical, a vertical example. And these two not only work on the current project together, but they've worked on several projects together in the past. So it makes sense that they would have a lot in common. But there are these spans across, which could indicate some commonality. There's an interesting pattern. So this person is a manager, and more people have the links are asymmetrical, which has to do with, I think, if other people are the source of information and they forward something to the manager, then there's more information flowing to the manager than reciprocally. Nothing of importance for this analysis. We were using someone else's visualization tool, and it just spit it out that way. Okay. It's actually a measure of the difference of outgoing matches and incoming matches.
How related were the projects to each other?
Actually, you can almost see some of that in the. Let me see if there's a useful way I can characterize this. This project, UAM, TSM, LW, Consolidarity, and Quality, these are actually all in the same group, organizational structure. So these two products are real organizational outliers in this group, as is the STE work. And this one shows a lot of very faint connections, less so than the other ones. So.
That one on the bottom is really interesting.
Yeah. Okay. So this was a summer intern. So he has a lot in common with. This is it's a little bit like a developer, but he's a research staff member that does mostly development work. So I think there was a tool that they used in common, which is why they had a lot in common. And they don't. Oh, I'm sorry. This is productivity file types. Yeah, I don't know if I have a good explanation, a story for that one. We didn't sit down and yeah. We didn't sit down and explore all the pairwise connections. Okay, so reflecting on what we've learned. Well, first of all, I'd have to admit that it was not as easy as it seemed or we hoped. At the beginning, we thought we had this really simple premise, just look at the files in common and see what patterns emerge. And it turns out that it requires a lot of filtering and processing technology to do this. And, we were looking at only a dozen or so machines. Scaling it up to the 300,000 plus people in IBM would be a lot more work. And so we'd have to figure out, we needed to do this kind of research to figure out how to focus it more scoped, in a more scoped way, to find the information that we want. And going back to the Amazon analogy, our data stream is much noisier than Amazon's because you only put a fraction of the information on your computer. A lot of other things put it on. So this is a little bit like if I buy something for a gift on Amazon, it pollutes the data stream. And I think they actually exclude that. There's that checkbox that says, is this a gift? And that adds other gift services, but I think it also deletes it from the recommendation data about you. But on the computer side, it's a much bigger problem. There's a lot more noise. But as we've already talked about, one of the things we think our approach complements these text analytic-based approaches by identifying, in fact, it's sort of biased towards finding graphic or video content because those are higher, more bits, more bytes of data. So
it seems like that exacerbates the problem with templates.
Mm.
The templates are often graphical templates.
Right.
How do you
right.
deal with that?
Right. You're getting there. So the template problem, I think, to deal with the template problem, one way to do it would be to work with the vendors of these tools to create parsers that throws away the template part of the file and analyzes the information content part of the file, which I think is actually regular enough that we could do. I've looked on there are some resources on the web that kind of break down PowerPoint file streams into different segments, and you could actually zero in on that part of it. So anyway, we think that it's an interesting complement to these text analytic approaches. In terms of what we learned on file commonality, I think one of the intriguing things is the relationships that show up are complementary to what you might find in a traditional organizational chart, or you would traditionally expect about people who work on similar things. So that's intriguing. Identical matches seem to indicate usage experience. That is, you and I use something in common, and so we're using the identical file. Whereas similar, not identical matches seem to indicate shared interests because you're working on or adding information to it. And a little bit surprising to us that the similar matches are more interesting for our purposes than the identical matches of finding out topics of interest.
We've seen, I think, some similar kinds of things going on with distribution lists and memberships and, common memberships and distribution lists. I wonder if you compared the results that you got from any kind of distribution listing analysis.
So distribution, meaning that people who are on the same distribution list would tend to have more files in common, or just their membership in distribution lists?
People who are on similar distribution lists.
I see. I see.
I take two random people in Microsoft, and they're not likely to share any distribution list. I take two people who have somewhat similar interests, and they're likely to share a lot of distribution lists.
Yeah, Shelley did some work where they built up a social network visualization based on that exactly, and then they had people sketch out their social network and kind of compare, and it was pretty similar.
I'm just wondering if we're looking at the same underlying set of commonalities, or if it's different.
One way to maybe get at that as well would be to include mail in
Yes.
your set of files.
Yes.
I mean, if you're just doing a hash in the mail anyway, you're going to probably pull some of that out. That's true.
Yeah.
Hash mail is difficult unless you can figure out where to intelligently.
Yes.
Because otherwise you miss things like forwards and so forth.
Yes.
So you weren't looking in mail.
I don't know what Shelley found, but distribution lists are highly confounded by all the ones you get put on automatically that tend to match the org chart.
It's the same noise problem. Yeah. Okay, so this discussion is about relationship to distribution list membership. So we didn't do that. Did we look at mail? So we did. Mail was one of the files that was analyzed unless the user excluded it. But mail in the IBM world is stored in this weird notes format. So we're not confident that matches based on mail would show. In fact, it's because of the 20% common metric, it's highly unlikely, because mail is one huge file per user, right? It's not chunked up into different files, at least the way. So that it wouldn't show up as a match. And it would only, at most it would say your mail files are in common, which wouldn't tell you anything meaningful.
Well, you would just have to crawl it. I mean, you'd have to
Yes.
have some kind of crawler that
Yes,
breaks
which
out.
we did not do. In part because we thought that mail would have more privacy sensitivities than files. So and would be a little more content specific. So we didn't do anything special about mail. But that I agree that this would be. I like about the way that this complements other ways of mining, again without any additional user effort, kind of interests or commonalities or grouping or clustering in a way that could be socially useful based on just what people are naturally doing.
Yeah. Website navigation, other things.
Website, right. So I think it'd be interesting to collect the various inferences we can make about people just from what they're naturally
The other thing
viewing.
that would work really well for is music. Did you guys think about that?
You know, we didn't. There's some. We asked about this music.
Killer
There's.
app.
It,
They did some work at Georgia Tech, actually, right? Looking at
shared playlists.
Steve Voida, I think, or Amy, one of the Voidas.
Yeah.
Looked at, they scraped all the music libraries that were visible and then did something with them to
I
compare.
have to look it up.
So in fact, the question was about music. Music files did not show up in common. I think because of the way they're stored. There's some. Our approach didn't show matches in music files, but I think that has more to do with how iTunes stores the files than. I'm sure there are people that had music in common out there, especially the summer interns. But okay, So learning about file management practices, to us there's a surprising amount of aggregate redundancy, and that validates this LiveWire value proposition of a backup and store system that goes across the enterprise. It made me wonder if there was evidence for rethinking deploying software. So there's this common, base of files that we're working on. It reminds me of the network computing architecture proposals in the past, where very little unique had to happen on the thin client on the end. To work further in this area, I think there would be potential if we focused on specific matches of interest. So again, when you're looking for non-textual matches, this approach appears to work well. If you narrowed it down to the set of file types, I think that would both reduce the complexity of all the analysis and would get at the more user-oriented information. And then this issue that we talked about already, writing specialized parsers for those specific file types that separated template information from user content. And then this is the temporal pollution along the way. We thought that access date would be an indicator of recent interest as opposed to stale. And actually, it could go both ways. The stale things would be maybe more surprising because they're not present in your mind, or you wouldn't detect that someone knew that someone in the past had an interest as yours. But as it turns out, many tools modify the access date, including our own crawler and LiveWire itself. So we actually now restore the original access date. We touch it and then restore it, but many tools don't do it, like desktop search and virus scanners. And so is there a need for an environmental protection campaign to preserve the metadata information and actually identify what is the meta information that's important for the mining things that we want to do today? And then how do we make sure that we preserve them relative to all the tools that are crawling our desktops? So here's a concept sketch of what we wanted to provide, but we didn't get to that point, which would be, so anyone who volunteered their data, it'd be interesting to give them some feedback of where they have commonality with other people. So we were thinking, could we, for example, treat people's folder names as a tag cloud, and you could, use some measures of how many files that folder had as a weight of how much that represents your interest. And then if you assigned a color to each person you had something in common with, you could colorize the tags according to where those commonalities had. So, in Consolidarity, I have some commonality with some people. Recent Shortcuts, another project, I have commonality with different people. And we could perhaps figure out a way of giving some evidence of what are representative files that you have in common with these people, again, to help you decide whether it would be worth taking the next social step of contacting them for more information. And I think
you'd access these files from this as well?
Our thought was not, so this is just a concept sketch, we never got that far, but our thought would be we would be presenting evidence, but it'd be up to people to take a social step to say, I noticed we have this in common, I'm trying to find out more information about it, and access it that way. Another thought we had was there are perhaps mechanisms where we could see if they already had access to the file, like if it was sent to them as an email or something like that, then we would treat that differently. And this was this notion of transitivity, which again we didn't get to. Can the structural relationships around a common file help us discover other information based on how you've grouped things? So visually, again, just conceptually, if there are two file directories and we have these three files in common, but in our respective folders we've grouped a bunch of other things that might be related, could we discover that other information through the commonality? This does break the privacy guideline that we had in the front, but maybe there's some metrics like, if there's enough files in common, well, first of all, maybe what we present is just data. You have several files in common among these folders, and so it could be a stronger indicator of how much shared interest you have based on, whether your commonality is in a shared grouped structure or not.
We have a project called Candid Tree that looks at two hierarchies and shows you how they differ, what things they have in common. What's interesting here is that using your tools, you could identify two hierarchies that do have things in common.
And yes.
Use something like the visualization that we
to show. Oh, interesting. Yeah, that would be very neat to do.
So something that's kind of like, I'm wondering if you could use, it doesn't have hierarchical information, But if you could do an analysis like this, for all I know, you guys are already doing this with, say, people who are dog ear users that have a substantial number of tags and shared tag kinds of things for, either your intranet or web kind of thing. Because it might be an interesting, similar thing where you don't have as many privacy issues because this is all public documents as well.
Right.
And the public tags.
Right. So I think this does complement or work well with publicly shared artifacts like tags. We haven't done anything along those lines yet, but I think that's an interesting. But dog ear in particular, though, is fundamentally different because it's about bookmarks, which are publicly shared information, and we are looking at files on people's hard drives, which are private, but usually not for for kind of convenience reasons, because we're not using shared servers in interesting ways. So, right, we see that as an interesting complement, and I think it would be a neat opportunity to aggregate all these cues about you have this in common: email, distribution lists, tags, files that you have in common, and use that to help increase or refine your social networking. So this poses some rhetorical questions about, are there unshared files on your computer? So there are, some of the files that we have are different because we're using different versions of the software, but that's usually problematic, not helpful. So unifying the files that we use could simplify software deployment. Then on your work computer, the files that we create, not as opposed to the ones we use, ultimately are intended to be shared with other people, by and large. The question is, whom are we sharing it with? When are you ready to share it? And that's an interesting difference. Before you share it with other people, you're worried about iterating on various drafts. Once you share it with other people, you're worried about making sure everyone has the latest copy and kind of keeping everyone up to date. So it'd be interesting to think about document diffusion kind of more socially than individually. And what's the mechanism that it will be shared with? So I think this potentially has implications for thinking about how to design web applications or wikis or web documents, ways in which we more naturally think of documents as a shared resource rather than as a private resource. So just to sum up, we found a surprising large amount of commonality among people, but making that meaningful requires a lot of filtering and processing. Our approach complements these text analytic approaches by identifying graphic or non-textual content in common, and it presents this sort of complementary or this piece of evidence that could be added to other pieces that help you kind of figure out social networking tools. So that was the journey. Thanks for your questions along the way. And I'm happy to address any more questions that you might have still. Yes.
It seems to me that one of the things that comes out clearly is you separate into three classes broadly: things which are program files, things which are your documents, and things which are shared documents.
Mm-hmm.
Maybe it's a theme level, your individual level. I have a lot of personal, regardless of what you think about it. This is my life, and my personal life is also here.
Right.
So I have my files which I'm not sharing with anybody. I have team files which, as you say, I'm sharing, and then program files which, for all practical purposes, I don't want backed up mode.
Right.
So the 9 years I've been here, every time I move groups, I buy another disk, put everything from the old machine onto this disk, and stick it in here. So
right.
Now I have like 370 gigabytes, which I'm trying to struggle to sort of reduce. Now, if I had I know that in those 370 gigabytes, I have 3 or 4 copies of Windows somewhere.
Right.
Like that.
Right.
If I had, what I would I was looking to see what the lessons I would learn from this is, and to me it seems partition and save these differently.
I
Is
see.
that a good summary?
Right. So, well, it's certainly, trying to summarize the question, certainly one of the things that we've learned is a bit of a taxonomy as you lay out the 3 kinds. I'm not sure if we thought about it as only those 3, but definitely, and I guess a slightly different layer is a difference between files that you use versus files that you create and modify. I think the extra dimension you're adding are what you might think of as truly personal files that you kind kind of want to keep, which and actually in our experience would be those files that get excluded that we never actually ever see because people are excluding them. So I think that is one thing that we learned. We kind of had a more refined understanding of how files cluster or how people think of or group their files in that way, and maybe ways in which, knowing that structure, we could be smarter about how to store, or definitely how to back up, but how to store and share files among each other. So I think, yeah, that's consistent. That's a consistent taxonomy from what we learned.
Do you know how much they did exclude?
How much did they? So this is an interesting question, and it has some interesting stories behind it. We were very deliberate about not asking because that was our privacy mechanism. However, I can tell you that the exclusion mechanism broke, and so, I'd load some stuff up, and I'd notice some files that I excluded in the match, and I go to the developer, hey Tessa, these files I excluded, they're showing up. The inclusion thing's not working. And she goes, oh, well, show me the files so I can figure out how to do that. I said, well, if I wanted to show you the files, I wouldn't exclude them in the first place. So, that's the problem we've got to solve. So we had these, and it broke a couple other times where we learned what people were excluding accidentally in that sense. But we were sort of trying not to touch that space. In general, speaking from my experience, I actually did exclude all my conference review stuff, and just some general personal stuff. Other example, there were some photo libraries that were excluded. You had a question?
How did you do the chunking?
Right.
Because I can imagine, depending on how that procedure works, you could
Right.
get more or less.
So the chunking algorithm, I'm actually not the best person to describe it, but it was based on a Rabin fingerprinting algorithm. So it's a pretty well-known in the space technology for eliminating redundancy in storage. So as I understand it, it looks for predictable patterns in the byte stream that indicate natural boundaries between chunks of information. And it's apparently regular enough to detect, the file structure is regular enough to detect these meaningful chunks so that you're matching meaningfully. But there's some this is a Kai paper, and there's some pointers in our paper to the references for the fingerprinting algorithm.
You said near the beginning that you had a fairly heterogeneous machine
yes.
So I'm wondering what kind of role these different kinds of machines.
Yes.
You can have the same file on different machines. I can imagine the
Yes. So let me go back to here. Hidden in the top, there's actually two different data sets. You might have noticed the first data set included some Windows and Linux machines. But when we moved to the chunking algorithm on LiveWire only worked on Windows machines, so we went only to Windows machines. In terms of diversity of roles, there's definitely some developer types as contrasted with, like me, I'm a user studies and design person. There were some summer interns. There were some people that were, just using this to remind me of there were some people that in a kind of distinguished engineer role in the research organization, he was the person that was making these proposals for funding. And there was one person that was basically IT support throughout the company. I would have liked to have gotten more diverse samples, like, administrative assistant, for example.
I was more pinpointing, I didn't realize that for the LiveWire part it's all Windows.
Yes.
That's really what I was curious about, because if you had a number of Linux boxes in there, or Apple.
Right. We would have liked to have done that, but for expediency of being able to do this chunking thing, we just used sort of an existing technology that we had.
So the commonality numbers, that was for any two people, right? The ones that you put up in the front, not for the whole sample.
Correct.
So how does it change as you go, 3 people and 4 people?
That's a good question. Let me get back to that.
How that relates to perception of this social structure or whatever. If I have the same file as a bunch of people, maybe I just sort of already know that.
So the question is about this. The table represents pairwise comparisons, and then the numbers on the bottom are aggregate across all 15. But we didn't do other subsets of groups, and I think that is an interesting exploration where it'd be interesting if there was sort of a knee in the curve, whether, and that might actually zero in on more interesting commonality. I guess the only other thing we did was the 70% cutoff, where if it was that in common, that kind of wasn't interesting. And that actually, we did an empirical study to detect that knee. The 70% threshold does appear to be where it becomes uninteresting more than 70%. But that's interesting. So I take that back. In that sense, we did do a bit of analysis, and I can't recall any more interesting features in the 2, 3, 4, 5, up to 70%.
Similarly, was the 20% rule you were using, do you feel like that was the best?
The 20% rule about matches in common, the template matches demonstrate that is flawed, but so there's a couple answers to that. We did a limited empirical study on that as well. So the 20% wasn't completely out of thin air, but better than playing with that threshold, I think, would be if you work through it carefully. And the reason why some of the edges are not symmetrical is that because you're always doing that 20% in comparison to one or the other file, right? So, but if you actually looked at them together, you might be able to weed out some of the template problems. Because if anyone stores a blank template, that has a high match with a lot of other files. And if you have that asymmetrical pattern, you could actually detect that and kind of conclude that this is a non-meaningful template match. But it wouldn't solve the cafeteria menu problem. That's just simply that templates and graphics kind of overwhelm the overall file size. So there are a couple of things you'd have to refine, I think, to filter that out.
There is some work on something called shingling.
Yes, which I think is a complementary way of, shingling is a complementary way of breaking down the file into pieces and detecting duplication. I mean, so I don't think fingerprinting is the only way. I'm not sure if they would be fundamentally different. The results would be different.
I think shingling is better for a variety of reasons. Shingling doesn't depend on the way it is chunked so much.
Uh-huh.
So there's a paper by Mark Nyort, Mark Manasseh, and a couple of others. They came through DEC and Compaq and so on and so forth, and finally they work in Microsoft Research in the Bay Area.
Yeah. So shingling as another mechanism. I mean, we basically used this Rabin fingerprinting mechanism because it was easy to do, but I think other approaches, yes. Well, easy for us because we had it like in-house, but I think you're right. There are other mechanisms that might actually improve some of the underlying technology.
The one other thing that strikes me is that when I was part of a big team, we were all pretty much forced to sort of subscribe to the source depot where everyone's files are stored. So and we were part of the Office group, and so I had about 95% of the files that I had in that directory were things that I couldn't care less about.
Right.
They were inflicted on us more than...
Right. So this is more evidence about the noise that gets put on our computer, not because we want it, because we inherit it from other...
It might be good. If you know team structure,
yes.
Then you might have a way to subtract this or...
Yes.
Another way of approaching that would be to know something about the processes that cause the things to be put on your machine in the first place. I mean,
right.
Anything that gets put on via Windows installer, you don't care about,
right.
presumably, because it's a program that you're installing, and you don't care about program files.
Right. Right. So I think, but this ends up going on a bit of a slippery slope. I mean, the original premise was no additional user work, and kind of a very dumb comparison. And in the end, we're finding that you had to be a little more clever about excluding some things, and they're not so hard, but it's a growing list. Yeah,
Do you
Corey.
provide the people participating in the study with these matches, and what was their feedback on it? Were they useful to them?
Right. So we had intended to provide that website mock-up of reflecting what matches were interesting to them, but we hadn't gotten to that point on the overall data because at the moment it's a little bit too raw. There's just kind of too much noise. It's a little hard to process. So the only experience we really had in terms of their reaction was that time when we there were 3 people that we sat down and said, let's open up some files and see what you think reaction. So that's so far the main feedback we've gotten from them. And a lot of that, I'd have to say, was, they were confirming that a lot of the matches were uninteresting or they were template matches. But then the gems were very interesting. So most of the conversation was about those slide matches or other documents that they had in common that were versions and kind of. So they're rarer, but that's the problem. The matches that are interesting are rare but rich. And so trying to distill that in some web display, we're not there yet.
And you could do the transitivity for files raises the privacy issues, but you could do it for people, which kind of gets you this friend of a friend social networking effect,
Right.
It could still be based on files.
Right.
But you could just show
For
the people.
some unknown
Reason. Well, see.
You and Brian have a lot in common.
Well, if I do the social networking, right, I may already kind of know, oh yeah, that person's fairly similar. I know you had these cases where people weren't really sure why, but it's that next link, which could be the interesting social relationship.
Right. So I think it's interesting, although we thought, well, we're going to have to provide enough evidence to make it worth the social effort of saying, So I think it would be awkward to say, for some unknown reason, I'm calling you to ask. But
Now, if I could see a list of sort of that had allowed me to visualize, here are my files, and there's somebody who I share this set with, and somebody who I share that set with.
Yeah, I see.
And you could start a negotiation with the other
Right.
people as to whether you might, whether there might be. That is, and I would be really interested in who
Yes.
I share these with if they're willing to, if they also are interested. I mean, you could see a way to traverse that path.
Yes.
You could also see who's reading all your papers. That'd be kind of neat.
Yeah.
Yes.
And using your slides. And,
Yeah.
and if they are willing to reveal that, and if they're not, well, that would be interesting too.
Yeah. I agree. So I think there's opportunity for clustering your files according to who they match with, and if those clusters match, if they in turn cluster around a set of people, I think that would be.
I could see that, in some cases, I'd look at these and say, well, that's another C program or something, and maybe of interest and maybe not, but this other set
Right.
would be one that I would be
Right.
interested in pursuing.
Right. Yeah, I think there are opportunities for alternate views or clustering or interactive, picking a file and seeing what people cluster around it and going. I think there are opportunities for doing that. We haven't approached that yet in our data set.
Another way to get around some of the privacy issues is to look at access to files that are on shares. Right, so they're already
The public ones.
already public,
Right.
and it's just based on who accesses them,
Yeah.
and when, and how.
That turns out to be, although there's some sense, as it happens, there's a certain amount of sensitivity because of the fact that most shares are not so highly discoverable. I just met last week with somebody with a project team, and I happened to know somebody in that group, and before that I kind of said, can you give me some prep? And they said, here's the share. When I got there and revealed that I had been looking at their share, even though it was public, they were quite bent out of shape with this team member who had revealed the share to me. So there are definitely privacy issues, even with supposedly public things that are not that easily discoverable, maybe. So that's just a side comment that I just ran into it Friday.
I think how this relates to shared file servers is interesting, but it turns out that in IBM we don't use very many shared resources. There's this other notes database structure which is totally impervious to this kind of analysis because it stores data in a different way. So we aren't able to explore the relationship between files that you have on your hard drive and files that are shared. But I think that would be an interesting additional link or bit of information.
So, jumping back to LiveWire for a second, there was a bit of discussion earlier about saying, well, if you've only got one copy of this, that you're potentially there's a
vulnerability
problem and so forth. But I mean, you turn it around and say, okay, well, look, there's 10 people sharing this. Why do you need to bother to have a backup copy on the server at all? I mean, you could start viewing this as you have metadata on the server which says here is where it is. If you lose your copy, you can do some sort of peer-to-peer file transfer and get it back. that way rather than even needing to store it. I mean, you might need to store it if you get down to, say, 2 or 3 copies of something. That's the point at which it starts becoming useful, where you've got, you know, less than 3 copies or something to actually have a redundant copy. But other than that, you know, as long as you've got sufficient bandwidth to spare.
Well, except there's a reason to have archival backup that's kept off-site in case there was a
Right, that's a separate issue, though. Yeah.
There's there's also discovery issues and stuff like that from a legal perspective. Depending on what the files are, a lot of times the legal department wants central copies of things that they can get to in case of discovery requests.
Sure, but that's not going to happen. It's sort of anyway. It's 200 gigas. There's too many files that people aren't going to want to keep in a central location because they want to have them on their laptop when they're not connected.
The point is that often you may have the automatic backup has this other
role, serves
role,
other right.
That's a good point.
Right. I think it is interesting how backup and restore could, in some ways, turn into a peer-to-peer file sharing or file locating mechanism. Yes. Yeah. LiveWire isn't exploring that currently, but I think it is an interesting opportunity. All right. Thanks for your attention. Sure. And all your questions.